Hi, grade 11 and 12. Let's look at this Newton's law question from a past paper. This is physical science, and this paper is for 2025 June, the routing paper. Ne? So they say that a person pulls a block of mass 12 kg to the right. So let's talk about that to the right first. So this guy, the object is moving to what? To the right. So I'll take right as positive. So all the forces that are going to the right, that will be positive. So they say that the block is pulled from point A to point B. We can see that point A to point B at an angle of 40. Okay, and then the coefficient of kinetic friction. What are we given? We are given the coefficient of kinetic friction as 0.31. Okay, so the block is pulled at a constant velocity. You see, they even put this in bold. Constant velocity means that the acceleration is 0 meters per second squared. That's what I need you to remember when we do calculations. So now draw. Now they want us to draw what? They want us to draw. Let's see what. Draw a label free body diagram. First thing first, please go and consult your exam guideline on how to define the term kinetic frictional force. We know that this is the force that opposes the motion of the moving object relative to the surface. So please make sure you go to your exam guideline and consult on how to work on that. Okay, so now what I'm going to do from here, let's work on 2.2, because now this is where they ask you to draw what? To draw a free body diagram. Indicate all the forces that are acting on the object. So when I indicate the forces that are acting on the object, the first one that I see there is the tensional force, which is applied at an angle. I'm just going to call this T for tension. Then we know that we have a force that opposes the motion, and this will be my frictional force. So the force that is going to the left, that's your friction. Remember, we said all the forces going to the right are positive, and the ones that will be going to the left will be negative. So we can see that this object is in contact with the surface, so it will experience what? A normal force that is perpendicular to the surface, Fn, or let's just call that F, or N, let's call it normal force, N for normal force. So this will be my N, and then we're going to have a force that always acts down, which is my Fg. So when you have your free body diagram like this, now it's going to be easy for you to do calculations. Please do not include the horizontal components yet and the vertical components on your free body diagram. But when you do calculations, it's very important that we include them. Let's work on 2.3. 2.3 says calculate the magnitude of tension in the rope. Before we dive into that problem, there's something that I need to remind you guys. Remember, we're going to have what we call a horizontal component, which is Fx, and we're going to have a vertical component that forms a 90 degrees, which is my Fy. So for now, since you are doing past papers and you are preparing for your June or final exam, already you know that your Fy and your Fx is equals to F the cos of theta, and you already know that your Fy is equals to F the sine of theta. So these are the formulas that we use to find Fx, and that is the formula that we use to find Fy. So you're going to understand why you need these two formulas when we continue working on this problem. So now look at what we have. They say calculate the magnitude of tension. So when you do the magnitude of tension, first thing first, we need to write down the free body diagram for all the horizontal forces, which is my Fx, that I know it will be F the cos of theta, and we're going to have what? We're going to have the frictional force. Let's call this Fk because we know that the object is moving. It will experience a kinetic friction. So now, what is F net equals to? F net is equals to MA. Then from this, what I'm going to do, we set right as positive. That was our direction. So all the forces that are going to the right will be positive. So on F net, we can take the force that is going to the right, which is Fx. Then you subtract the forces that are going to the left, which is Fk, and this is equal to what? This is Ma. So this is your normal force. So this is the formula that we're going to use. Now let's talk about what is Fx and what is Fx and what is Fk. So the Fx is my horizontal component, which is the formula that I'm going to use. So now I know that my F, this F here is my tensional force. So Fs will be T the cos of that angle. So Fs will be T the cos of that angle. Let's quickly substitute that. Okay, let's quickly substitute that. So if we say this will be, let's put this on the calculator. Fs, it will be T the cos of that angle, which is 40 degrees minus. Let's talk about Fk. What is Fk equals to? Guys, remember the force is applied at an angle. So if the force is applied at an angle, how does this affect the normal force? So we have a vertical component that will reduce what? The normal force. I'm not sure if you guys understand when we say it will reduce the normal force. Let's quickly work on that. So to understand how we calculate the normal force if the force is pulled at an angle, you're going to draw a free body diagram indicating all the vertical forces. How many forces do we have that are vertical? We have 1, 2, which is Fy, 3, which is Fg. I'm going to draw a free body diagram. Let's quickly put our free body diagram down here. So now we set that we have the normal force going up, and we also have what? We also have Fy going up, then there's Fg going down. So now remember, we can say F net is equal to, these are vertical forces. So the F net is 0, and then now we can take, maybe let's choose direction and say we take up as positive. So we're going to add all the forces, which is Fn, the force of normal force. We add that to what? We add that, in fact, let us not use that. Let's just say normal force. Okay, so now we are saying that to find the normal force, we're going to add all the forces that are going up, which is the normal force and your Fy. Then we subtract all the forces that are going down. Let's equate this to 0. So if we equate this to 0, what is the normal force? Normal force will be the Fg goes to the other side to be positive, then the Fy comes this side to be negative. So this will be Fg minus Fy. So you can see that if the force is pulled at an angle, this reduces what? This reduces the normal force. So the formula that you need to find the normal force, it will be Fg minus Fy. So now let's talk about what is Fg, what is Fy. So this tells you that the final formula for normal force will be Fg is just the mass times the gravitational force minus what is your Fy. If you still remember, the formula that we're going to use for Fy, it's F, the sine of theta. Let's not forget that our F is T. So this will be T, the sine of 40. So this will be T, the sine of theta. And if we do the substitution, my normal force will be the mass times the gravitation. The mass is given as 12, so this will be the mass times the gravitation. So this will be 12. We're going to multiply the 12 by what? The 12 by 9.8. Therefore, we minus t, the sine of that angle, which was 40. So now, when we calculate the normal force, this is what we're going to subtract on our question. This is what we're going to subtract. So hopefully when we do this, you won't get confused, you know? So now if I say 12 times 9.8, if I say 12 times 9.8, what is that equals to? So 12 times 9.8, this gives me 117.6. So the normal force, it equals to 117.6, then minus t, the sine of 40. So now we know what is normal force. But remember, we are looking for Fk, okay? Fk, the frictional force, we are looking for Fk. What is the formula for Fk? What is the formula for Fk? So the formula that we use to find the kinetic friction is the coefficient of kinetic times the normal force. Do we have the normal force? Yes. Do you have the kinetic friction? Yes. So now I'm going to say, let's rewrite this in a way that everyone can see how we're going to substitute this. So we're going to say my fx, this fx, we know that is the horizontal component, which is equals to f the cos of theta. So this will be t the cos of theta minus fk, which is uk, times the normal force. This is equals to, what is ma? We're just gonna leave that for now, then we'll substitute that. So this will be t the cos of 40 degrees, we minus the kinetic friction, which was given as what? 0.31. So I'm just going to substitute this as 0.31, and then everything inside, we're going to multiply this uk times n by what? By a negative. So now we need to put what? We're going to substitute this as your normal force. We're going to put that there as your normal force. Let's quickly substitute this. This will be 117.6 minus t sine 40. So we're going to multiply this by 117.6, which is minus t sine 40. Minus t, okay, it's minus t, the sine 40 degrees. I hope you guys understand what is going on, and I hope you guys see why we need to put it inside the bracket, because the negative multiplies everything inside that bracket. The negative will multiply everything inside that bracket. Okay, so when we have this, now we can equate this to what? The ma, remember the acceleration, they said this moves at a constant velocity. So if it moves at a constant velocity, what is the acceleration equals to? So the acceleration is 0. So this will just be equals to 0. Now let's solve for t. Let's solve for t. So when we solve for t, what I'm going to do, I need to isolate t. So I'll need to isolate t, okay? So let's quickly work on this. Let's quickly work on this. I'm going to have this as, let's say that we first multiply the bracket by negative. This will be the cos of 40 degrees minus 0.31, which is multiplied by 117.6, close the bracket. Then this will be plus the 0.31 times t, the sine of 40 degrees, and this is equals to 0. So I'm going to take these two guys. Let's take this to the other side to be positive. I'll explain why I need it out to be positive. So we're going to equate this to what? That 0.31 into 117.6. I'm not gonna use a calculator for now. So this side I still have the t, the cos of 40 degrees, plus 0.31 t, the sine of 40. Let's take t out as a common factor. Then I'll have the cos of 40 degrees plus 0.31 the sine of 40. So we just take t out as a common factor and let's see what we have. So this is 117.6. So when I have it like this, I can just divide both sides by whatever that I have inside the bracket. I can divide both sides by the cos of 40 plus 0.31 the sine 40 degrees, and divide also this whole thing by the cos of 40 degrees plus 0.31 sine 40. So meaning that when you punch this on the calculator, we should get t, because these two terms cancels. So let's see what is our tension when we put that on the calculator. What do we get as the tensional force? Okay, so when I punch this is 0.31 times 117.6 divided by the cos of 40 plus 0.1, 0.31 the sine 40. So this gives us the tension of 37.77 newtons if we round this thing off. So this is your final answer for tension. So I hope you guys understand what we did on this one, and I hope you guys are happy, because if we can quickly do a quick recap. First thing first, indicate the horizontal forces that are acting on the object. Once you have the horizontal forces, most of the time if they just want to look at the mark, this is just 5 marks. So now when we have it like that, after indicating the horizontal forces, we choose direction, then we take it from there. Just know what is fx, which is f the cos of theta, what is fk, uk times normal force. But now we see that the normal force won't be equals to fg only. Why? Because the force is pulled at an angle. This tells you that that vertical component there, the fy will reduce what? The normal force. I hope you guys understand. It reduces the normal force. So now let's work on the next question. They said that the block is moved horizontally a horizontal distance of 24 meters from A to B. So the distance here from A to B, the distance, we are given the distance as delta x, it equals to 24 meters. Right, so with that distance, they say that calculate the time it will take the block to reach B. So before I do that, you know what I'm going to do? I'll first look at what I'm given. They said that this the block is pulled at a constant velocity of 10 meters per second. So I'll just write down my data, which is what I'm given. So if we do that, let's see what we have on this one. So what are we given? V initial as 10 meters per second. So this is 10 meters per second. But remember, this thing is going to the right. That's why my initial velocity is positive. Then if we go back to the statement, what else do we know about this? We are looking for, we know that the acceleration, they said that this thing, it moves at a constant velocity, which makes the acceleration to be 0 meters per square. So now, what else do we know? Delta x, because this is a horizontal component. Delta x, it's equals to 24 meters. So this is what we are given, and they want us to find delta t. I think you guys can see that we're going to use equation of motions to calculate this guy, to work on 2.4.1, we need to use equations of motions. So I'm just going to write this down, 2.4.1, equations of motions. So please go to your formula sheet and look for the formula that doesn't have V final. The formula that you choose, it must have all this information but not the final velocity. And the formula that I'll go with is this one. The formula that I'll choose when I work out on this one, I think it's best if we take the one that says delta x. Please don't say delta y, since we're working on a horizontal. This is delta x is equal to v initial delta t, then we add half of the acceleration multiplied by delta t squared. This is the one that we need to use. Therefore, you can just do your substitution. What is delta x? 24 meter. And equate this to your v initial of 10 meter. This is 10. Then we are looking for delta t, which is the time. They said calculate the time it will take to reach point B. So the time it will travel from A to B. Calculate the time it will take the block to reach B. Okay, so this will be plus 1 over 2, the acceleration is 0, delta t squared. So now we can see that this guy here, everything here, it's multiplied by 0, which will make that to be 0. So when we work this thing out, what do we get? When we work this thing out, what will be the final answer? So now I'm going to have this as 24 meter. It's equals to, let's not include this when we do the substitution, okay? So 24 is equals to 10 delta t. Divide both sides by 10 because we are looking for time. Divide both sides by 10. Then what is delta t equals to? Just punch that on the calculator. Let's see what is delta t. So delta t is 2.4 seconds. So this is 2.4 seconds. So the time that it will take to move from point A to point B is 2.4 seconds. And that's how we answer this 2.4.1. Let's see what we have on the next questions. Let's see what we have. 2.4.2. It says that if the block's velocity is increased to a constant velocity of what? We are increasing this to 20 meters per second. We are increasing the constant velocity. How will the frictional force be affected? How will the frictional force be affected? So now, before we answer this question, let's focus on the frictional force. So remember, how do we calculate the frictional force, guys? So now if I answer this to the question 2.4.2, first thing first, I know that the formula that we use to calculate frictional force is Fk is equal to the coefficient multiplied by the normal force. So it's the coefficient of what? The coefficient of kinetic friction. You take that coefficient of kinetic friction, you multiply that by the normal force. Okay, let me quickly work on that. So this is UK times normal force. So look at this. We know that this is my kinetic friction, this is my coefficient of kinetic friction, and this is the normal force. So the kinetic force does not depend on the speed. I'm not sure if you guys understand that. So the kinetic friction, the Fk, the kinetic friction does not depend on speed, because you see that when we calculate Fa, we don't have any V in this equation. So it does not depend on speed. So this tells you that the surface stays the same. Okay, so did we change the surface? No. And then the mass stays the same. Because remember, to calculate the normal force, we're going to use the FG. There's also FG when you calculate the normal force. But now, remember, the mass stays the same. They did not change the mass. The angle of the rope stays the same, because remember we said normal force is equals to what? The normal force, the formula that we use for normal force is this one. This is the formula for normal force, and we have the angle. So the angle stays the same, the mass stays the same. So this tells you that the change in what? If we change that, if we change the velocity, nothing will happen to our FK. So to answer this question, the kinetic force remains the same. Why? Because it depends on the coefficient of friction and the normal force, not the speed of the block. So the answer is remain the same. And they don't want you to give a reason, you just choose and you get that 1 mark. Let's go to 2.2.5. The angle between the rope and the horizontal surface is increased to what? We are increasing the angle to 50 degrees. So what happens if we increase the angle? So what will be the effect on kinetic frictional force acting on the block? So now we are changing the angle. We are changing the angle. Let's work on this. Let's work on this and see how will this affect our frictional force. Let's quickly work on this. So now let me just put this on the board and see what we can do from this information. So first thing first, remember that when the angle is when the angle increases, so theta increase according to what? To the statement on 2 point, or that was 5.2.5, 2.5.1. So they say this increases, we are increasing the angle. So what will happen? The upward component of the let's work on this. So the angle increases, then we know that we need to find our Fy, right? So Fy is equals to T, the sine of theta. So if Fy is equal to T, the sine of theta, remember this guy here, this, it reduces the what? It reduces the normal force. Right, it reduces the normal force. Since it reduces the normal force, the formula that we use for normal force is equals to Fg, we minus the Fy. And this is the same as the normal force, it's equals to mg minus T, the sine of theta. So that's the formula that we use for normal force. So since we use the formula for Fk, the formula for Fk is Uk times the normal force. Now look at this. Look at this. We are increasing the angle. We are increasing what? We are increasing the angle. So now, and this is the formula that we use to calculate the frictional force. So what happens to the normal force? What happens to the normal force? So remember, if we increase the angle theta, this will reduce the normal force. So increasing angle theta, this reduces what? It reduces the normal force. Right. So since it reduces the normal force, we're going to have a smaller normal force. What is that meaning? It means that we're going to have a smaller kinetic friction. Why? Because frictional force is directly proportional to the normal force. If the normal force increase, the frictional force also increase. So this reduces the normal force, and then therefore we can conclude and say that our Fk, the Fk also decreases. So the correct answer is decrease. The correct answer is decrease. So you can choose decrease, and they said give a reason for your answer. So you know what you're going to do? You're going to say to write this thing. So the correct answer there is decrease. And the explanation that you can give them is that as theta increase, we know that this the Fy increase. If theta increase, this increase the Fy. Right. What happens if the Fy increase? This tells you that the Fy increase, remember Fn, the normal force is equal to Fg minus that Fy. Right. So the normal force decreases. Therefore, this tells us that the normal force decrease. Right. So if the normal force decrease, and this will also make the kinetic friction to decrease. And ladies and gents, that's it for this lesson. This is how you collect that 19 mark. Thank you very much for watching. If this is your first time watching the lesson and you liked the lesson, please make sure that you hit the subscription button, leave a comment, and make sure that you join us on the next one. Thank you, guys.